So in the warm-up, we reviewed how to graph a line when it's written in standard form. So standard form allows us to easily find our x and y intercepts, and you can use what's called the cover-up method to find the x-intercept, cover up the y term, set the x term equal to the constant, divide by -1, your x-intercept 6. To find the y-intercept, cover up the x term, set 2y equal to the constant. Y has a y-intercept of -3. You can use this method because if I'm sitting on the x-axis, I have a y value of 0. When I plug 0 into that, then that term goes away. Same goes for the y-intercept. I have an x value of 0. If I plug 0 into x, cover that up, the x term goes away, and I have 2y equals -6, so y is -3. Then all you need is 2 points to graph a line. So you graph your x-intercepts, and you connect the points, and there's your line. Now, what's more important is the solution. When graphing a function, no matter what type of function it is, the solution is all the points on that function. So any point that falls on this line is a solution. So 0, -3, 2, -2, 4, -1. All of these points are solutions to this function. So we looked at another function, 4x minus 3y equals 12, graph the line, and all the points on the line is the solution. So what happens when I change my symbols? What happens when I start throwing in symbols like a less than, a greater than, or a less than or equal to, and a greater than or equal to? What does it do to my solution? So when I throw in a symbol like a less than, and in this situation it is the less than only, my solution is not going to be the line anymore. The reason why is because the line is considered part of the boundary, but it's not a part of the solution. If I pick a point on that line, like 0, -3, and I plug that in, 0 plus 2 times -3 is -6. -6 is not less than -6. It's equal to it. So any of the points on the line is not part of the solution anymore. That less than tells me I want to shade below. So the line is not the solution, but all of the points below that line is part of the solution. Now in the second situation, we had a less than symbol, but notice how we shaded above. Well, the reason why is because I have a -y. If I was to solve for y by subtracting the 4x and then dividing everything by -3, anytime you divide by a negative, you always have to flip your symbol. So the way I look at it, if I have a -y right there, then I know I'm going to have to flip my symbol. So it's not going to be a less than anymore. It's now going to be a greater than. And so we shaded everything above the line. So what happens when I put these two together? How does this lead into systems of inequalities? So when we graph two of these in the same coordinate plane, our solution is now going to be all the points. It's still going to be everything they have in common, but it's going to be the overlapping region. You see, to solve a system of equations, we find their common or shared points. But when we're shading, we have a lot more common or shared points. So all the points that the two lines overlap and share is our solution. So you're going to be learning how to graph systems of linear inequalities, and then keep in mind Desmos is always an option.